and the application is a front end where the whole application was deployed in the cloud environment. So essentially it was an enterprise content management system running in a cloud apps. Technology and components involved were APIs, OAuth, you've heard of, SAML, SOAP, AJAX, etc. So it's a completely web-based application running in the cloud, fetching information using API and authentication using OAuth and some of the single sign-on mechanism which was addressed by SAML. So that's the whole application. This is one of the biggest challenges we are seeing is how you scan the application. If the application is residing in the cloud or application is using a lot of Web 2.0 component, how do you scan the application? Because you start scanning the application with the open source tools or say product, it's not going to scan because the whole application is a one-page application. There are no actions. So like you go to the one page and then you identify, oh, that's another resource, that's another resource, that's another resource. It's not going to be that framework anymore. So all different tools were drastically failed in the cloud environment or Web 2.0 environment if they're using the open API or such. So then we did manual audits and assessment, and some of the interesting things were discovered SQL injections over APIs. So we had a traditional SQL injection, now we identify these SQL injections over various different APIs. So our concept would remain the same, but the payload delivery capacity or capability would drastically get changed. Another interesting area was a mobile interface. This particular application running in the cloud can be accessed by 2 or 3 different interfaces. You can use iPhone or you can use your Chrome browser or typical web browser. So they had very modern application running on the web applications, but they had the interface for mobile devices. So actually what you can do is, like when we did assessment on a mobile application, we found the access over there. So and those accesses are running on the same platform. So like say for example, if I send you that particular URL on your mobile URL on your web URL, so simply what is going to happen is you are going to anyway going to get cross-site scripted. So these are one of the weakest links which we are seeing in the environment. That one environment or one interface is very hard. The second interface, which is like going over a mobile or some of the trusted zone, are not that hard. So there was interesting finding on a mobile interface. Authorization bypass on the other content, so we are able to actually start to access others' content which is on the same cloud app, running on the same VM. So that's where interesting finding came along. Information leakage through JSON fuzzing. JSON is becoming a very popular medium for exchanging trivial information in sometimes. Or in sometimes we see heavy banking information or heavy telecom information actually going on a JSON file. So we were able to do a JSON fuzzing. We started to do a lot of JSON fuzzing. JSON is a very typical protocol. We may not go into detail, but essentially you look at the JSON string, and when you send your payload, you have to make sure that you have exactly craft the JSON in right fashion. And depending on a library to library, their structure is getting changed. So, say for example, if you don't inject double quote, then you're going to get an error from the JSON parser and not the actual backend code. So that's where some of the challenges which we are seeing. CSRF, cut across applications, we are able to identify virtual sandbox bypassing and mobile interface compromise. So this is a typical analysis which we did with a few apps and some of the issues which we discovered in these apps. Full software will be get rendered to you. Say for example, now Microsoft is running with the full services of Office. So now you don't have to install Office. You just borrow Office license on the cloud and just open your browser and access the Microsoft interface, which is exactly same what you are looking on your desktop. So this is where 3 different layers will going to get accessed in the cloud. And you have 4 quadrants of the cloud over here: infrastructure, platform, service, and software. In infrastructure, you have Amazon EC2, Sun, Grid, CloudWatch, RightScale, platform, Google App Engine, Force.com. Services would be Maps, MobileMe, Amazon Service. Software would be a Salesforce, ScanSafe, Google Apps, etc. So this is the fourth most important quadrant in the cloud. And bird eye view will be clients and application layer, platform, infrastructure, and physical server. And then we just quickly go through like a physical server would be a computer resources, storage resources, database, etc. Infrastructure layer would be this layer provides abstraction over physical resource, so you don't have to worry about where your memory is. You just make an API call, whatever you want to access, you access over it. It's essentially known as infrastructure as a service, IaaS platform or IaaS. These are providing using hypervisors or VMware kind of a companies who are providing these kind of a services or these kind of a software. So essentially you just access your OS image over here and access the complete resources. So you have a virtual instances running of hypervisors and you just start accessing those machines or those resources. And then this is the way how it is going to get segregated. You have actual hardware which is running on the core processor, then the hypervisor will come into action and then it will segregate users depending on what they have purchased, what OS they have purchased, what middleware they have, and then what kind of apps they are running with. So this is the way how the whole virtualization would get done. Over here, it also allows you to allocate number of machine cycles and frequencies, etc. So the whole hypervisor thing would sit over here. Functionalities of hypervisor, security through segregation of parallel VMs on the same machine, and this is one of the most important part when you do the threat modeling in the cloud is this. Say for example, you have a virtual VMs running, and when I access a virtual VM with the admin, I may have a firewall in between. But once you have access rights on a VM, where is the firewall? Whether my VM and other VM sitting next to me in between there is a firewall is there or not. So if you start sniffing on your VM and try to look at the traffic, if you see other packets, that means you are like the other VMs are already compromised, because now you can see what is going on into the next VM which is running on your same rack. So there are a lot of different way the threat modeling of the cloud applications or a cloud infrastructure has to be done. Some of the infrastructure which we have evaluated where when you ask for a memory, actually memory is going to go over a network, because it's not like a physical memory. It's like a virtual memory. So when you say, okay, this is my VM, I want to access this particular file of my VM. So when you are on the box, the file is right there. So you just access that. But when you are not on the same box, the actually VM or a hypervisor will go out and fetch your file from somewhere in the cloud and then give the access to it. So this entire memory stack is going to be transferred on the network. So when these kind of a sniffing is going on, you are actually exposing your memory as well. It's not just the network traffic. You are actually someone is actually looking at your memory as well. So these are some of the side channel attacks or side channel issues which we have seen. Some of the companies which are providing is Exen, Amazon services, GoBreed, etc. Microsoft with the Azure platform. Then the storage companies are out there. Provide needs to take care of backups, universal access to the data, etc. EMC2, Amazon Web Services, Nirvanix, Parascale, etc. out there. And then coming to the platform, this layer actually provide a much more abstraction to the operating system level, provide a constraint in the platform, programming language, tools, etc. So it comes pre-built. The whole platform is ready. You can say like, I want this particular OS, I want this particular application server running. Say for example, I want to buy a platform for a WebLogic. Then you get the whole suite of a WebLogic loaded on the platform, and you are leveraging the platform. So various different services out there, the platform as well. So platform as a service is another important layer which we have. So again, a platform would be application 1 and application 2. That would be the customer control, and the abstraction of the below would be done by the hypervisor over here. So development providers provide a development environment specific, particularly programming language, provide the custom APIs, and customer can concentrate on the application development, upload their code executables whenever done, and then the customers or clients, the end clients will come and start accessing it. So if we take a case study of Google App Engine, for example, currently supports development in a Java and Python platform. So provides a customized API called Google App Engine, and then whole whole environment you can actually load. So you test your application locally. Once everything is fine, you just upload the code and it will start working on the platform. So you don't have to buy anything. It's like just your application runs in your environment and load it. They will maintain everything below that, whatever languages the support which you have asked for. So download a toolkit from Google, develop the code, test it locally, upload necessary precompiled files. There are certain APIs which you have to use in certain fashion when you are accessing the Google APIs. So for example, if you are using built-in Google's authentication mechanism, or you are using a built-in Google's mail services, then there are certain APIs which they give you. So essentially what you are doing is you are interlinking everything on one platform. So Google also provides statistical numbers of visits, data transfers, server loads, bandwidth use, memory usage, etc. on the same platform. Other providers are Windows Blue Platform, Moss is there, Tennisys is there, Post.com is very popular, Enjoyment is there. So these are some of the companies which provide various different platforms. And then when you're looking for the data marts out there, the main application logic is transparent and location of the data storage. So essentially it allows you to store your data, be it in any form, be it a binary or a clear text. So Amazon SimpleDB provides a customer as a web interface. You can provide two classes of commands: create, modify, update, delete data set, and retrieve data. All these are essentially get over REST applications. So it's a REST-based call, you go back and forth, and you can actually go ahead and upload all your data. One of the major players in this case is Oracle. Oracle has a Oracle on-demand services, which is very popular nowadays. So banking, a lot of different clients are using this, where they just buy Oracle services. Amazon has a relational database service as well, which is called Amazon RDS. They are trying to compete with the Oracle over here. SimpleDB is not RDBMS essentially. The Oracle, this one which they have launched in a beta service is RDBMS.
What is LongJump?
LongJump is another provider for data services.
It's RDBMS?
It's RDBMS. And then comes the application layer, provides of course their own application and services in the cloud. Customer pay or subscribe for it. Customer has no control over infrastructure, network, OS, storage, application, etc. Because all the abstraction has been now at the application layer, so you don't have any control below that. And this is very popularly known as a SaaS, and this is the bulk of the vulnerability which we are going to see in a cloud in the next couple of years would be coming from the SaaS. Enterprise application like human resources, management tools, new employment, CRM, you name it, and all these applications are going in the cloud, running in the same cloud. Maybe two competitors sitting on the same VM and accessing the same cloud database. So these kind of scenarios which are now emerging, mail, character, docs, sites, videos, etc. are the most popular means for the cloud SaaS. And then on top, what we are looking at is the Web 2.0 applications, which are heavily running with services like mobile wiki services, various blogs, network sites such as Facebook, etc. will be the typical Web 2.0 application running in the software as services. And then now we have like one software service is talking with another SaaS, or one SaaS talking with another PaaS, or one PaaS talking with another IaaS and such. So like now we are like a one cloud talking with another cloud. Still we are dealing with the one cloud. We are still dealing with the one app, and the whole industry is moving on the feature ground way ahead. So a lot of complex mechanisms which we are seeing in the cloud or outside the cloud. Lot of different protocols. If you say, for example, you look at the whole generation of AWS security protocols, or you look at the OAuth, or you look at the OpenID. All these different protocols, SAML, all these different protocols, if you look at, these different protocols are actually built for accessing two different networks on the application layer. So whether you are running in one cloud, which is like, say for example, your application is on Facebook, and another application is say for example on a Google, how you can these two clouds can communicate once your identity is the one and the same. So these are some of the 2.0 applications which are addressing these kind of requirements for the future. Another way of looking at this is with the cloud sandwich. You have infrastructure, metastructure, and infrastructure. infrastructure, metastructure, and infrastructure. This is another way of looking at the cloud environment. And depending on the company's philosophy and depending on